morning students. So welcome to the session number 25. Okay, in the present session we would like to discuss about types of nuclear reactors. So in the past session itself we are discussing about two types of reactors. One is the pressurized water reactor and second one is the gas cooled reactors. Okay, so in a pressurized water reactor, so what we are doing is, so in that we are using the pressurizer to pressurize the water for cooling a nuclear reactor. Okay, in a gas cooled reactor we are using the gas for cooling purpose as a coolant, as a gas. So we are using different types of gases in that. So that is carbon dioxide, helium and all. So in the present session we are discussing about a few more nuclear reactors. So especially in the students class we are focusing on two reactors. One is the boiling water reactor and second one is the fast breeder reactors. Okay, so any aim of a nuclear reactor, type of a reactor in this we are discussing about a coolant only. So here the firstly focusing on boiling water reactor. So here we are using a lightweight water here. Okay, so different types of reactors are available. So already we completed the pressurized water reactor and the gas reactors. And today's class we are going to discuss about boiling water reactor and breeder reactors. Okay, so these are the breeder reactors. So now we would like to go into the boiling water reactor. So what is meant by a boiling water reactor? So a boiling water reactor, BWR, is a type of light water nuclear reactor. We are using a light water, H2O only. Okay, but we can utilize for generating the steam as well as it is to the cooling purpose. Okay, so the same water we are using for a steam generation purpose and we are using for a cooling purpose itself. Okay, so lightweight water, when we are using a lightweight water, so here we don't require any pressurization system. So that's why directly we will take the H2 as a liquid material here. Okay, so why we are using this type of a boiling water reactor? So generally the boiling water reactors are using for power generation purpose only. Okay, so water absorbs the heat. What happens in a nuclear reactor? In a nuclear reactor, continuously heat is generated. So that heat is absorbed by the water, lightweight water, and that water is converted into the steam format. See here, water absorbs the heat from the reactions in the core and is directly driven to the turbines. So what happened with the water? So that water is converted into the form of steam. So that steam is used to run the turbine. So there we will get a mechanical energy. Okay, if you see this diagram, okay, so what are the components of a nuclear reactor here? So in this diagram we can clearly mention that. So the main important concept is the reactor vessel. So in this reactor vessel we need to place down the fuel rods here, okay, and control rods. So what happens with the fuel rods? The fuel rods are continuously taking place the fission reactions. Okay, so it's a chain reaction. So chain reaction means it's continuously release the amount of heat energy. But we would like to control that heat energy, otherwise it takes a blast of an entire power station. So that's why we are using the control rods. Okay, so the control rods are continuously we are placing here. Okay, and here after that here we need to send the water. So that water is sending to the reactor core. Okay, in a reactor core that water is absorbs the temperature or heat energy and that is converted into the form of steam here. So here if you see the steam, and the steam is used to the operating of a turbine. So steam contains high velocity, so that means high kinetic energy. So high kinetic energy is used to run the turbine and generate some mechanical energy. After that, that mechanical energy is converted into the electrical energy by using of a generator. So after the power generation process, so we need to connect that electrical power to the grid, and from grid we are supplied to the homes. Okay, so the thing is we are using the lightweight water, and the lightweight water is directly absorbs the heat. If you see the pressurized water reactor or the gas cooled reactor, two chambers or two primary circuits are there. Primary and secondary circuits are there. But here we have only one circuit. Within the one circuit we are completing the process. Okay, and So in a boiling water reactor, enriched fuel is used. So what is meant by enriched fuel? So enriched fuel means we are injecting some active contents or impurities for proper and better reactions. That is a man-made process, man-made fuel we are using. The boiling water reactor uses to demineralize the water, okay? And as a coolant and moderator we are using water only. So here we are using coolant as a water and the moderator also a water. So what is the difference between the coolant and the moderator? So here coolant is removes the heat from the reactor core and moderator is slow down the process. So slow down the velocity of content. So that is the moderator. Heat is produced by the nuclear fission process. So it's a fission is a controlled process and the fusion is a uncontrolled process. Already you know very well. So fission in the reactor core and this causes to the cooling of water while producing the steam. So here what happened, the continuously heat is released, the heat is absorbed by the water and that water is converted into the steam format. Okay. So this is the working principle of a boiling water reactor. And see the cyclic diagram here. Okay. So it's a very important of a layout of a boiling water reactor. So in this chapter the main important thing is layouts of a power plants. So PWR or gas cooled reactor, boiling water reactor, homogeneous reactors and fast breeder reactors. Every reactor we need a layout. Layout is a very important. Please follow the layout. So what are the components of a layout? First you need to remember the components. Once you can remember the components, so you can easily draw the layout. So the thing is, the first thing is we need to feed the reactor. So feed pump is required for sending the water to the reactor. So what happened in the reactor? So in this reactor we have a fuel rods and control rods. So what happened with the fuel rods and the control rods? So the fuel rods are continuously releasing the heat energy and that heat energy is controlled by a control rods. So here the fuel is for example uranium-238. So if the fuel we are using the uranium-238, so it is one nucleus is collided with another nucleus and it is split into the neutron, small atoms. Okay. So this is the chain reaction is takes place and these are the neutrons. So these neutrons are not absorbed by the fuel rods and these neutrons are absorbed by the control rods. So the control rods are using to absorb the neutrons. If it does not absorb the neutrons, the reaction is continuously takes place. That reaction is a fusion reaction. So here we are saving the water and that water is absorbing the heat liberated in the reactor vessel. So after that is converted into the steam format. Okay. So the second important component is the reactor. Okay, is the reactor. After that, so some amount of steam is bypassed here for condensation process and high quality steam we are taking into the turbine. Low quality of steam is bypassed for condensation into the water format. So which is have a superheated steam, that steam only we can passes through on the turbine. If it gives a high amount of energy, so that energy we are utilizing for generation of a electrical power by using of a generator. After the expansion of a steam in a turbine, so this is a turbine, here the steam is entered and strike of a blades of a turbine. So when the strikes steam in the turbine blades, automatically that steam starts the expanding process. So that expanding process, the steam is condensed and that condensed steam we are collecting into the by using a condenser here. So some amount of 50% of steam is converted into the liquid format, but it is have a high, very high temperatures. Okay, so that the steam we are taking the condenser part. So condenser is a device. In this condenser we are convert the entire steam part into the liquid format. So condensation already do you know very well. In a condensation, two types of condensations are there: film condensation and the boiling condensation, drop-wise condensation. Okay. So the most of the condensation is takes place in the condenser and it requires the cooling water supply. So from where we are supply the cooling water, from the outside we can arrange one sources for the cooling water supply, and the cooling water is using to conversion process of a steam into the liquid process. And from that point we are feeding again to the feed pump, and the reactor process is going on. So this is a continuous cyclic process. And if you need any excess amount of water, we can supply from other sources also. So always we are sending the very lightweight water only here. Okay. So this is a working principle of a boiling water reactor. BWR. The main difference between a BWR and the PWR is, so already do you know the PWR, and right now we are studying about the BWR. So what is the main difference between these two? The reactor core heats the water which turns into the steam and then drives a steam turbine in a PWR. In a PWR what happened? The reactor core heats the water which does not boil, because already it has a very large amount of pressure is there. Okay, high pressure is there. At a high pressure, the water doesn't convert it into the steam at a low temperatures. It requires very high temperature for conversion of a water into the steam. So that's why in a PWR, if you see the two cycles, circuits, one is the primary circuit and the secondary circuit. So that reason in a primary circuit, so no amount of water is converted to the steam. In a secondary circuit only it converts the steam into the liquid format. From the secondary circuit only we are sending to the turbine of a steam. Okay, so that's why in a PWR there is no direct contact of a water and a turbine circulating water. Okay. And what are the best advantages of a BWR? In a BWR, boiling water reactor, the best advantage is heat exchanger is not required here. Okay, so if you run a power plant in a two stages, primary circuit and secondary circuit, at that time you need a heat exchanger device. But here, heat exchanger circuit is not required, so direct conduction hence more thermal efficiency in a BWR. Okay. So in a by using of heat exchanger means it takes a conduction process by using of another equipment. Okay, after the primary circuit we are sending back to the water. In the secondary circuit it absorbs the water energy, and that secondary water is converted into the steam. But what happened in a BWR? In a BWR we are directly sending the water into the reactor vessel, so easily it converts to the steam format. That's why efficiency is very high for a BWR. So what is the next content? So ease of low pressure principle, hence no need of pressurizer. So here there is no question of a pressurizer. Okay, so automatically if you reduce the pressurizer, it reduces the cost also. That is also one advantage. And metal temperature remains low. So we don't require very high temperatures in this, but in a PWR we require very high temperature due to the cause of it is already having high pressures. And outlet temperature of steam is very high as compared with a PWR, because it's directly contact with a nuclear reactor core from the water, so that's why the outlet temperature is very high. And what about the last one? Pressure is low and thicker vessel is not required. So the pressure of a water is very less. If the pressure is increases, automatically it's trying to move outwards. So at that time, the forces acting on the boiler container very high. Maybe it takes blocks of a containers. Okay, so that's why it requires very large and thick boiler containers for a PWR. But in a BWR, we don't pressurize that much, so no need of a thick vessels. Okay, so these are some advantages of a BWR boiling water reactor. At the same time, the BWR having some disadvantages. So now we would like to discuss about a BWR disadvantages. So what are the BWR disadvantages? So disadvantages of BWR, it's a more elaborated safety particular. It requires more elaborated safety particulars needed which are costly. So why it requires most elaborated things. Okay, so because here we are directly contact with a boiler, directly contact with a reactor, that water is flowing through the pipelines. Okay, so maybe it causes to any type of a radiation problems. So that's why we are using very accurate and particular equipments that may be costly one. And wastage of steam resulting in lower thermal efficiency on part load. If you run that engine or if you run that nuclear station, part load means half of the load or less than the maximum load. Okay, so lower load of a value. For example, if you want to construct a one power plant with a capacity of 100 megawatts and if you require only 30 megawatts of power, so only we are applying the 30% of a load. So that at that cases it gives a very less efficiency. Okay, and the possibility of radioactive contamination in the turbine mechanisms. So here the water is directly contact with a core part. So automatically that radiation parts or radiation particles are directly contact with a turbine also. Maybe it causes to a problem of a turbine mechanism. So that's why it's have some disadvantages. Okay. So the thing is lower thermal efficiency at a part load conditions. Please remember that point. At a higher load conditions, obviously it's a high efficiency when compared to the PWR. Okay. And coming to the second type of a reactors, that is a breeder reactor. So breeder means it elaborately divided into some other particles. Okay. So a breeder reactor converts fertile materials into the fissionable materials. So fissionable means it gives a more amount of heat energies. Okay. So fissionable materials like uranium-238 we can convert, it's a fertile material, so that is converted into the fissionable material, that is a plutonium-239, and thorium-232 is converted into the uranium-233. So beside the power production, so it's a process of conversion of a materials in a fertile material to the feasible materials. Okay, so here the thing is the conversion of a materials. Okay, so what are the different types of a reactors? Two types of a nuclear breeder reactors are there. One is the fast breeder reactor and second one is the thermal breeder reactors. Two types of reactors are there, fast breeder reactors and thermal breeder reactor. So now we would like to discuss about fast breeder reactors. So FBR, fast breeder reactors. So under the appropriate operating conditions, the neutrons given by a fission process. Okay, so here the fast breeder reactions are can be breed more fuel. So breeding means combined with some other fuels. Okay, so that is known as the breeding conditions. So breeding is more fuel. So production of fissile materials in the reactor. So that converts fertile materials into the fissionable materials. So the production of a fissile material in the reactor occurs by the neutron irradiation of a fertile materials. Irradiation of a fertile materials, particularly uranium-239, 238 and the thorium-238. So uranium-238 is converted into the plutonium-239 and the thorium-232 is converted into the plutonium-238. So what is the thing here happened here? The most common breeding reaction that is the plutonium-239. Uranium-238 is converted into the, after taking a one neutron, it is converted into the plutonium-239. So here also say uranium-232, sorry, thorium-232 TH, thorium-232 is converted into the uranium-238 by absorbing the neutrons and all. Okay. So these are the reactions takes place here. Also, breeders can design to utilize the thorium, which is more abundant than the uranium, liquid metal uranium. So the most abundant element in the earth is the thorium. But we require the uranium material because that is the most feasible material as the uranium. So that's why we are converting the fertile materials of a thorium into the feasible materials of a uranium-238. Okay. So here, generally we are using uranium liquid metal reactors or sodium graphite reactors in the further production process of electricity. Okay. And what is the reactor types of reactors here? So in this breeder reactor, so this is a one breeder reactor. So here, if you see that in a pressurized water reactor, if you see in the two parts only, two circuits only. But here, if you observe the three circuits, okay. So the first one is the sodium radioactive, sodium non-radioactive materials, and the steam circuit. So three circuits are there: primary circuit and the secondary circuit here. Okay. So what happened here and what happened there? Okay. So here, the thing is, we are sending the water at a low pressure pump, and that converted it absorbs the reaction and it is converted into the some liquid content to steam. And here we are using the sodium materials also. So sodium Na and the potassium, sodium potassium NaK here. So sodium is the radioactive material here, and that is converted into it changes the heat energy. So this is one heat exchanger. So in this heat exchanger, it transfers the energy from one circuit to the another circuit. After that, that sodium is again we are using for the non-radioactive type. So here that is directly contact with a reactor vessel. That means it have a more radioactivities. Okay, but later in this case it is not directly contacted, so that's why it's called as a non-radioactive content. So here again we are using one more heat exchanger. So heat exchanger, what is the function of a heat exchanger? In a heat exchanger, the temperature is transferred from high level to the low level. So automatically when the reactor is directly contacted, it is have a high temperatures, and second one is absorbing the temperatures. So here also it finally it creates the steam. So that steam is flows on a turbine. Okay. So here the steam is converted into the form of a mechanical energy by using of a turbine. Okay. So that turbine is connected to a generator, and excess amount of water or expanded steam is converted into the liquid format by using of a condenser component. So this is the part of a breeder reactors. This reactor consists of a double circuit coolant. Okay. So enriched uranium is used as a fuel here. So already we discussed that in a breeder reactors it converts to the fertile material into the fissionable materials. Okay, and here we are using the double coolant circuits. Okay, primary circuit and the secondary circuit, and here we are using the enriched fuels. So liquid metal and the alloys such as sodium, potassium as coolants. Okay, and what is the moderator? Here we are used graphite as a moderator in this. Okay, so in a breeder reactors we are using graphite as the moderator, and sodium, potassium like that materials we are using as a coolants. Okay, and here sodium has a high thermal conductivity which is more than 100 times that of water. So that's why we are using sodium as a material here. Okay, for better thermal conductivity values. Okay, hence increases the thermal efficiency of the plant. So when we are using the high thermal conductivity material, automatically it shows its effect on the thermal efficiencies. Okay, so that is the thing in a fast breeder reactor. If you observe that it have a higher efficiency when compared to the PWR or the BWR in a fast breeder reactors. So here the primary circuit uses the sodium as a coolant and absorbs the heat from the core and transfer to the sodium or sodium potassium. Okay, NaK uses alloy as coolant. Okay, in the secondary circuit what happened? So in the secondary circuit, sodium potassium transfers heat to the boiler to rise the steam. So in the secondary circuit only we are generating the steam content. Okay, so which is used to run the turbine power. Okay, that is the working principles of a fast breeder reactors. And what are the advantages of a fast breeder reactor? In a fast breeder reactor, the moderator is doesn't require the moderator. Okay, and high breeding possible. So it have a breeding process is continuously doing, so high breeding process possibility is there, and small core is sufficient. Here we are using the sodium, okay, so that's why it's having a highest amount of thermal conductivity. That's why we don't require the very high amount of a core parts, and high burn of fuel is achievable. So it's a good efficiency and good burning. So when the fuel takes place proper burning, at that time we will require very less amount of fuel. It is enough. Okay, and absorption of the neutron is low. Okay, so absorption also low in these conditions. And the last thing is that thermal efficiency of the plant is very high. It is around 30 to 40%. So previously we were discussing that the fast breeder reactors are very high efficient when compared to the PWR and the BWR. Okay, so that efficiency around 30 to 40%. And but it has some disadvantages also by using of a fast breeder reactors. So what are the disadvantages of a fast breeder reactors? So the first thing is it requires a very high enriched fuel. So it's a costly fuel. When we are using the natural content, that is a lower price. But if you want to do any enrichment process, it is a very costly process. So that's why it requires a very high enriched fuel, and cost of the functioning is very high. It is necessary to provide a safety against meltdown.